The main has joined. What happened to Sindhi people? Netra, Raga? Only two. What about others? Not mass. Okay. They're still in the school because they don't miss the classes. That's all. Still, it's going on today. Okay, metals and non-metals, extraction of the ore. You people come this side, na? First. I should be able to see you people. Sit here only, no? What is the problem? First. Okay. See, for sports day, annual day and all, don't miss the classes. I'm really telling, don't miss for these things. Now, 10th time, whatever you have, it's very much important. And again, I'm repeating. Now, from 2 years, they are not giving marks for the steps also. The question paper will be tough only. Now only I'm telling. Seriously, I'm telling. Listen, CBSE question paper is also will be lengthy and it is tough only. Only you will be able to complete only when you practice very well. All the tricky problems you have to practice now. Once you know everything, all the concepts, start practicing tricky problems. That only will come to the exam. That is, I'm very much sure. I'm telling. From 2 years, I'm observing. Question paper also will be difficult, and correction also it is very stingy way they are doing. So you have to learn properly. Otherwise, it is really difficult. Now only I'm telling. Okay. See, who have expected 90 also, score will come to 65. That also we can come. Many people in last year, might say 35, 40 they've got. At least after teaching, yeah, I've seen many kids like that. In CBSE, I'm telling, it's not a joke. Don't do it seriously. Take that. Study well. If you study well, you can get 99 also. It depends on you how you will do. Okay, we will give all the support, but you should sit and study. Clear? Sit here. I should not talk. Okay. Understood? Seriously, everyone should study. Okay, metals and non-metals now. In metals and non-metals, we are doing about the extraction of the ore. So what is a ore? Where you can extract the metal economically, then it is called as a ore. Okay, so in the metals, we can bifurcate as highly reactive metals, medium reactive metals, and the low reactive metals. So highly reactive metals. Highly reactive metals are sodium and potassium. They are the sodium and potassium. Okay, they are sodium and the potassium. So highly reactive metals, you cannot use any reduction method to do that. That is, usually will be in the oxide form or a sulfide form ore. Okay, so what you cannot reduce those metals by any other metal, okay, or any other substance. So what you have to do, you have to use the electrolysis process only to for very highly reactive metals. For the extraction or the purification of the metal, we have to use electrolysis process. Electrolysis of molten metal. Molten metal means it is in the liquid form. Metal is in the liquid form. So you have to do electrolysis process. And electrolysis process, it is one of the efficient method or the effective process. Okay. Electrolysis process, it is one of the effective process what we can use where the efficiency is very much high, more than 99.9% of pure metal we will get. Okay, so when you want to extract a highly reactive metal like sodium and potassium, you have to use the electrolysis of molten metal only. In first chapter also we studied about electrolysis of water. Do you remember? It splits into hydrogen and oxygen. So same process we will use here. Okay. Then comes the medium reactive metals. In the medium reactive metals, we have the sulfide ores and the carbonate ores. So carbonate means what? As a group, it is CO3. Carbonate means what? It is CO3. What is its valency? 2. Its valency is 2. Okay, carbonate group or the sulfide groups. So carbonate, it has a carbonate ore means what? With the metal there is a carbonate. Okay, it is a carbonate of that metal. That is, carbonate group is added to that metal, then it is called as a carbonate ore. Sulfide ore means what? If you are adding, if there is a sulfide group in that, then it is called as a sulfide group. Okay, so both can be reduced. How to purify these metals? That is the medium reactive metals. One is the calcination, other is the roasting. That is, whenever it is a carbonate ore, we do the calcination process. Then after the calcination, it will be reduced into oxide form. For example, zinc oxide. From zinc carbonate, it forms the zinc oxide. Then zinc oxide, again it is reduced into the metal. Then it is purified by electrolysis process. Okay. So brief idea. Again, I repeat, see, whenever they're in the medium reactive metals, there can be carbonate group, that is carbonate ore. Means what? It contains the carbonate group with that. Sulfide ore, it contains the sulfide. So carbonate group means what? CO3, its valency is 2. Example, zinc carbonate, ZnCO3, like that. So that it is by the calcination process, it is reduced into zinc oxide. That is the oxide form. From there, it is reduced to the metal. Why it is reduced? We say oxygen is removed from that. That way, it is reduced. So it is reduced to a metal. Then it is purified by the electrolysis process. Okay. So then sulfide ore means there you use the roasting process. From there the oxide metal you will get. Then it is reduced to the metal. Then the metal it is purified by electrolysis process. So we'll write the equations about that. This much you understood, right? Extraction of metals. What is that? Extraction of metal. Write down. Metals of medium reactivity. Write down. Metals in the middle of the activity series of the reactivity series, such as iron, lead, copper, zinc. Okay. So the metals in the middle of the reactivity series like iron, lead, copper, zinc, okay, these are moderately reactive. They are moderately reactive. These metals, right? Are these metals are usually present as sulfides or carbonates. They are obtained as sulfides or the carbonates. Okay. Sulfides means examples. Yes. Sulfur will be there. Sulfide ore example. Zinc sulfide ZnS. Zinc sulfide. Carbonate ore ZnCO2. Okay. So sulfide means sulfur will be there. So ZnS. Carbonate ore is carbonate group will be there. ZnCO3. Okay. Now, usually the metals which are moderately reactive, they will be found in the earth crust as sulfide ores or carbonate ores. Not all, it's most of them like that. Okay, sulfide ores and the carbonate ores. Sulfide ores means it contains the sulfur, that is ZnS is one of the example. Carbonate ore means they contain the carbonate, so CaCO3 you can tell. Zinc ZnCO3 like that. Okay, carbonate valency is 2, zinc valency is 2. So you will get ZnCO3 only. Okay, ZnCO3. Now, how to purify or extract the metal from this sulfide ore? So first we do, for the sulfide ore, we do the roasting. For the sulfide ore, we do the roasting. Roasting means what? It is heated with the oxygen. Roasting process means it is heated with the oxygen and it is converted into a oxide. Again, I repeat, see, roasting means it is a process in which metal is heated in the presence of air. In the presence of air means always in the presence of oxygen. Okay, so there we call it as roasting. In this process, we will get the oxide of the metal. For example, zinc oxide, ZnO you will get. Okay, right down. So roasting, what example you have? Zn, yes, plus the oxygen. What you will get? Zinc oxide plus the sulfur dioxide gas. First, write the equation and then you can balance. Don't practice balanced one only. Most of the time you go wrong. Okay. You should know zinc oxide means ZnO. Why? Zinc valency 2, oxygen valency 2, cross multiply. 2 zinc reacts with 2 oxygens. That's why ZnO. Like that. So zinc oxides plus the sulfur dioxide gas will get. See here again, I repeat, zinc oxide you are getting, you know, what else is remaining? Sulfur dioxide. So you will get sulfur dioxide. Some people, they have seen sulfur only will not be there after the reaction, or they will write some other thing. Don't do that silly mistakes. Huh? YouTube opened up the TV, ma'am. What happened? Oh, okay. I didn't see. From that time, I would have not told. So extraction of metal of medium reactivity. So first in that you can have most of the time either you will get sulfide ores or the carbonate ores. It's not only those two, but it is a common one what they've given. Okay. So for the sulfide ore to extract the metal, first we do the roasting. In the roasting, what we do, we combine that metal or heat that metal with the air in the presence of air. That means in the presence of oxygen. So you will get here example zinc sulfide plus oxygen. You will get zinc oxide plus the sulfur dioxide gas. Okay. Why SO2? SO2 is then. SO2. And then zinc. Now, like oxygen is balance it. Balance. Oxygen, no, oxygen is 2 as 2 as sulfur 4 you will get. No, then zinc as 2. So sulfur should be you have like sulfur where you have different valencies. How you have in iron also. Okay, that's how you will get sulfur dioxide. Here the valency is 4. What you're asking is correct. Zinc valence, sulfur valency here 2, here it is 4. Correct. It comes with different valences. It comes. That's how the equation is. Okay. Write down faster. Oh, good, you saw that observation. And even in sulfur, different valences come. Sulfur trioxide also will come. SO3 also will come. Where when you heat SO3 will come, SO2 will come, so many things.
Sulfate SO4. It even has 8.
Correct. When only sulfur elements will be there, 8 which will combine with this.
8
8 when 8 S8
SO4.
SO4. SO4 will sulfate. SO4 it is not the valency here. There 2 is there, no? 2 minus is that sulfate. So it can be 8 right there. Still 2 is required. You are understanding what I'm doing. That's so different. Right now. Pass done. Gavin done. Pass done. Next. Right now. When you have the calcination process, right? Next, the calcination process. When we use the calcination process, when we have the carbonate ore, we use the calcination process. Okay, when we use the calcination process, when we have the carbonate ore, then we use the calcination process. What is calcination process? Calcination process means it is heated in the absence of air. That is, it is heated in the absence of air, then we call it as calcination process. Okay, write down.
So the byproduct will be carbon dioxide.
Correct. It is a process in which carbonate ore, write down, it's a process in which carbonate ore is heated below its melting point, in the absence of air, to convert into metal oxide, okay. So what you will get, zinc carbonate when it is heated, so what you will get, zinc oxide plus the carbon dioxide gas. Okay, zinc oxide with the carbon dioxide gas. So, medium reactivity metals like iron, zinc, and all. What is it? Delta is heat. So, calcination. It is a process in which, medium reactive metals like iron, zinc, and all, we have most of the time either it will be sulfide ores or the carbonate ores. In the sulfide ores, the first process will be roasting. Roasting means it is heated in the presence of heat, that is oxygen, in the presence of oxygen. So there it will be converted into oxide of the metal. Second one, whenever we have a carbonate ore, it is heated in the absence of air, that is in the absence of oxygen. So you will get zinc carbonate, you will get zinc oxide plus the carbon dioxide. Okay, so in both the process, it is converted into oxide of the metal. Why it is converted into oxide of the metal? Why it is converted? Why you have to convert into oxide of metal only? What is the reason? What is the reason? Some reason will be there, right? To convert.
You have to reduce it up.
See, reducing from oxide to the metal, it is easier. That's why they convert into zinc oxide. See, why it is converted into oxide? Reason is it is easier to convert oxide of the metal into or reduce the oxide of the metal into the metal. It is easier. That is why first it is converted into oxide. Okay. Write down. Next. After this process, what will be the next process? Next process is reduction to the metal. Write down. Reduction of oxide ore. Reduction of oxide ore. What we do here, it is the process in which, write down. It is a process in which it is a process in which metal oxide metal oxide is reduced. Metal oxide is reduced into metal. It is reduced into metal. So, example, zinc oxide plus the carbon, you will get zinc plus the carbon monoxide. Zinc plus carbon monoxide. Zinc plus carbon monoxide you will get. This time you are getting carbon monoxide. Earlier you used to get carbon dioxide. When you will get carbon dioxide and when you will get carbon monoxide? Whenever the oxygen is more, then it usually converts into carbon dioxide. Otherwise, it converts into carbon monoxide. Okay, so carbon monoxide. So reduction of the oxide ore. In the oxide, what happens? Oxide of the metal is converted into metal. That is, it is reduced into metal. And here,
Calcination, the oxygen is less, but it's still carbon dioxide.
for the oxygen, here it is carbon, zinc carbonate is there. Oxygen is 3 there. And why we are heating with the carbon? Because it is a reducing agent. That means reducing agent means what? It will take the oxygen from some substance. That is the reducing agent. That's why it is heated with the carbon. But in sodium and potassium, if you heat it with the carbon, it will not reduce because they are more reactive than the carbon. So carbon cannot reduce there. And these questions they ask in the exam. And these questions they ask, okay, Gavin understood what I told now? Can you repeat? Before that, what questions I told? Huh? So these questions they will ask why it is not heated with the carbon or why it is reduced like that. What is the reason is carbon is a reducing agent, that's why we are using here. But whereas with sodium and potassium, you can do that. You cannot reduce by heating carbon and all. What is the reason? Because it is sodium and potassium is more reactive than carbon, where carbon cannot reduce that metal. Okay, that is why we have to use electrolysis process only there. And here we can reduce by using the carbon. Okay, write down first. Write down thermite reactions in this one. Thermite reactions. Very important. They will ask many questions regarding this thermite reactions here only. Write down. What? Write down, no? Fast. Manganese oxide plus aluminium. So you will get manganese plus aluminium oxide plus the heat. Okay. Another one, iron oxide plus the aluminium. You will get iron plus aluminium oxide plus the heat. Huh. So here the reduction by oxide to the it is reduced to the metal. Okay, oxide of the metal is reduced to the metal for the extraction. So in that we can also use the displacement reaction. We can also use the displacement reaction for this reduction of the metal. We can also use the displacement reaction for the displacement of the metal. Okay. So displacement reaction means what? One metal or one high reactive metal will displace the low reactive metal from a substance. That is called displacement reaction. So that can be also used for the reduction of the metal. And if you observe here, we have written L liquid, right? Iron and manganese here. It is written as L. Correct? Do you observe? L means what? Iron is in liquid means what? Liquid state. It is in the molten state. So, what should be the temperature? It should be very high. Correct? It should be very high. So why it is in the molten state? Because it is an highly exothermic reactions. So we can use displacement reaction also to get the metal, but they are highly reactive reactions and exothermic reactions. They are very highly exothermic reactions, and it is so exothermic that we will get the metal what obtained in the liquid form, that is in the molten form. Okay, these reactions are called as the thermite reactions. And where we use the second one is in the railway tracks. Think in the railway track, there is a crack in the railway track. Okay, listen this. These questions they ask in the exam. Railway track, there will be a crack. So to repair that, iron should be melted. There you should bring 3000 degree or 2500 degree, correct? No? So getting that much, it's very difficult there to melt it and become then to remove that crack. So what they will do, there they will use the thermite reactions. So anyway, on the track, whatever is there, there will be iron oxide because rusting will be there, right? That when they heat, that track will be there, right? There, if the crack is there, they will heat here with the aluminium. When they heat with the aluminium, what you will get? Iron will be in the molten state. Plus the aluminium oxide, since it becomes in the molten state, that crack will be filled. Understood? No, the crack will be filled. That's how they repair the railway tracks.
You told that it is written as Fe3O4.
Huh. If it iron oxide will be there, right? There.
You told Fe3O4.
Huh.
You have written Fe2O3.
You will have both. You will have all the type of reactions. That's what I told. Sulfur, iron, and all. You will not have always the same. You will have changes because valency will vary 2, 3, and all. And there also valency, because you have both 2 and 3, it will become Fe3O4. Okay, it will vary. Here it is Fe2O3 only, it will be there. Correct.
So how do you want to know should it be?
Depending on which reaction you are writing, you have to write. Iron, sulfur, and all, we will have different valencies because their electron distribution, you will have different way. That's why you will have. Depending on, see, where, which one we have to use, it depends on which compound is formed, how it is formed. Sometimes heat is more, it will be different. Sometimes catalysis is different, it is different. Or with different compounds, they will have different valencies. It depends on that. Other parameters also it will differ. It both are existing. Fe3O4 is also there, Fe2O3 also there. Okay. So Fe2O3 plus the aluminium, you will get iron plus aluminium oxide plus the heat. Okay, iron plus aluminium oxide plus the heat you will get. And here we get iron in the molten state, where because it becomes in the molten state, that cracks can be removed from that. So there we will use the thermite reactions. Thermite reactions are used. Okay. So here, when you are writing the thermite reactions, you have to write iron in the liquid form, and here also manganese in the liquid. Okay. You will get all the type of reaction. Fe3O4 is also there. Fe2O3 is also there.
And if you write Fe3O4 also, it will be
It will, but reaction then you have to balance. Yeah, that's it.
then FeO also exists.
Actually, Fe3O4, how you will get means Fe2O3. Okay, here valency is what? What will be the valency here? 3. And here FeO is also there. Valency is 2 and 3. Both exist. Together, they call it as Fe3O4. Okay, we will have both. Even with sulfur, SO2 is there, SO3 is there, so many is there. It depends. SO2, when it is formed, when oxygen is less. When you heat it with more oxygen, then it will become SO2. So that's what in chemistry, like different parameters depending on that you will get. So many things will change.
How is potential displaced?
Potassium displaced by electrolysis process only they do that. Because no other way you can displace, because it is only highly reactive. That is why you can't use displacement reaction. Only electrolysis process is used. Reduction. It's a purification of the metal obtained from the reduction. That is, from the metal oxide, you will get the metal, right? That is purified by this method. Okay. The common method used is the electrolytic refining. Electrolytic refining. It is electrolytic refining. And this one also very much important, electrolytic refining. What is that? Write down this. Nickel. Write down a solution. A solution of metal salt. Of metal salt is used as an electrolyte. It is used as an electrolyte. Correct. Is used as an electrolyte. You write down, I'll explain. When electric current, when electric current, yeah, when electric current is passed. No, we cannot use. That's why only we are using.
It will be negative and this zinc will be positive.
Huh.
Then we can use it as electrolyte.
Electrolyte. Salt, yeah, you
And
can
then we can
directly use in the
we don't
electrolysis
need
process.
this word calcination process.
That is easier. At the end, doing electrolysis is easier. That's why they do that. Otherwise, directly electrolysis only you can do. Anything you can do. But it is easier to do in this process than that. That's why they do that. But for sodium, potassium, there is no other option. That's why they do directly electrolysis first. Okay. See, not only the possibility, you have to think economically and which is possible like that. Many things will be there, many parameters will be there. So, depending on that, they use the method. Okay, there will be many other methods also. It's not like the only commercially which can be used in a large mass, which is better to use and which is economical to use. Both the ways which is possible that they will try to use. Directly also you can use actually electrolysis, but it is easier to do in this process when compared to what we discussed. That's why they do that. Okay. Right now, when electric current is passed, metal ions from electrolyte. You want to go out? Huh. When electric current is passed, metal ions from electrolyte are reduced as metal, which get deposited, on the cathode. An equivalent amount of pure metal from the anode gets oxidized to metal ion and goes into the electrolyte and goes into the electrolyte. And from there, it goes to cathode and deposit. So electrolytic refining. So in the electrolytic refining, we use the electrolysis process. In the electrolysis process, what we have the two electrodes. One is the cathode and the other is the anode. One is the cathode, other is the anode. Cathode is the one which is negative in charge. Cathode is the one, it is a negative terminal, whereas anode is a positive terminal. Okay. So in electrolysis process, you will have two electrodes, one cathode and the other anode. Cathode is a negative terminal which is connected to the negative terminal, that we call it as a cathode, whereas the one which is positive connected to the positive terminal, we call it as the anode. And we have an electrolyte. Electrolyte will be the salt of that metal. Okay, for example, if you want to purify the copper, when we want to purify the copper, we will take the cathode and the anode will be there. And anode is a thick metal, impure metal we will take. And at the anode, we take thick sheet of impure metal. Okay, we will take the impure metal. And cathode will be a thin sheet of pure metal. Okay, thin sheet of the pure metal. So what happens when current is passed through the electrolyte? When current is passed through the electrolyte, for example, here you have copper sulfate as the electrolyte. When current is passed through the copper sulfate, we get Cu plus and SO4 minus. Here it is 2 plus and 2 minus. Copper 2 plus and this is 2 minus. Okay. So copper, which is an positive ion, get deposited on the cathode. Again, I repeat, see, electrolyte what we take is copper sulfate here. Okay. When current is passed through that, copper sulfate, which it will ionize into Cu2 plus and SO4 2 minus. Cu2 plus, it's a positive ion, gets attracted towards the cathode and it gets deposited at the. And we have here only SO4 minus, right? So what happens in the anode, we have the copper. So copper ions gets attracted with the sulfate. Then you will get C plus SO4. You will get copper sulfate. Again, first copper sulfate here will get this, it will split into copper plus SO4. Copper ions gets deposited at the cathode. Now SO4 ions will be there from the anode. Copper plus the sulfate, you will get copper sulfate again. Again, copper sulfate will split into copper plus SO4. These ions will get deposited in the cathode. So in this manner, the anode, which is having the impure metal, only the pure copper metal will get deposited here. And the any impurity will be settled down as an anode mud. And why we use for purification? Because here pure metal what we get is more than 99% pure metal we will get. That's why we use this electrolysis process. Clear? Again, I repeat, in the metals, how to purify the metals? Most of the time we use electrolysis process. In this, we have cathode and anode, two electrodes. Cathode means it is connected to negative terminal. Anode means it is connected to the positive terminal. Okay, electrolyte will be the salt of the metal. For example, copper sulfate, when you are purifying the copper. In the purifying of the copper, electrolyte will be copper sulfate. Anode will be a thick impure metal, copper, which you have to purify. And cathode will be a thin pure metal they take. Okay. So first, when current is passed through the copper sulfate splits into copper plus the sulfate ions. So copper sulfate, the copper, these are positive ions, gets attracted towards the cathode. So they get deposited on this electrode. Okay, on the cathode it gets deposited. Now we have only SO4 ions, right? From the copper, from the anode, they combine with the SO4 ion. So you will get copper sulfate again. Again, this will split into copper plus SO4. Cu plus again gets deposited at the cathode. So this process continues where only the copper gets deposited at the cathode, whereas the other impurities will settle down as anode mud. This is how it is purified. Clear? So this is electrolysis process. And just the next comes the corrosion is there.
When all is given, but electric current is passed, if your metal from the anode dissolves into the electrolyte.
That's all.
Pure metal from the anode.
Anode only. That's what I told.
Anode is into metal.
In the impure metal, only the copper gets deposited, comes out. Like in evaporation, what happens? Salt and water both will be there. Only water gets evaporated. Correct? That's how it is purified. Here also, from the anode, only the copper gets combined with the sulfate. That again splits and again it deposits at the cathode. But whatever the impurity will be there in the metal, that will settle down as anode.
Anode is
Impure metal only, but from that, only the pure copper metal will combine with sulfate ions. Then again it will split, again that copper will get deposited at the cathode. Understood, na? That's what happens in evaporation, no? Like that only. How clouds are formed? Salts and water both are there in the sea. But salts will be there only. Water only gets evaporated and that forms the clouds. So that's how it is purified. Here also, only the pure copper only combines with sulfate. And that again splits and settles at the cathode. The impurities, whatever is there, most of the time they get like settled at the anode mud. Okay, it will be like anode mud.
Can't we do this with water?
Water, yeah, you can do.
Then
What do you if you just want to split water, it will become hydrogen and oxygen. That only they are using for green energy, nowadays. Hydrogen, they call it as green energy. So hydrogen is used as a fuel. They do electrolysis only there.
Can't we just produce pure water? If hydroxide later.
They're using in deserts and all, like Dubai and all. They use water purify from the sea water. There they do this only. All these process you can use. That's what how economical you can use.
Why not India?
It is costlier. You have to put that big plant, maintain that cost. Everything matters. That is the matter. Okay, you can use everywhere. You can use how economically you can do, how commercially you can make it success. That is also you should see. In deserts and electrolysis, somewhere they would have written in the paper. See, it is there. You can use. Okay. So we'll stop here. I think most of the things we did. Only the corrosion is there. No, what is corrosion and how to prevent that?
Yes.
Corrosion means what? It actually reacts. Any metal, it may react with the water or some atmospheric gases and it forms the unwanted substance. That is the rust iron, what we see, that it is an unwanted substance. So like that, even in the copper we see green coating. So that is also an unwanted substance which is produced by some chemical reaction. So that we call it as corrosion. How to prevent that? Painting, galvanization, then greasing. All this we can.
And give the probability.
Probability, yeah. Next. That's why I did little bit faster. So
This is not even there.
you are not there. Others
What do you
many others also have. That's it. Okay. Online. Okay. Understood now. So next we'll do probability. Here we will end the today's class. Do not forget to subscribe the channel. If the content of this channel is useful, Please like the video and share with your friends. Thank you.